Question answers on carbon and its compounds. First is ethane with molecular formula C2H6 has how many covalent bonds? The answer is 7 covalent bonds. 7. We'll see about this, how these are 7, because there are certain questions relating to this. Butanone is a 4 carbon compound with functional group ketone. Ketone is the answer. So the functional group of butanone is ketone. While cooking, if the bottom of the vessel is getting blackened on the outside, it means, so if you're cooking and it blackens here, that means the fuel or the gas burner, the gas coming out of it or anything which is used as a fuel is not getting burned properly. B is the answer. Explain the nature of covalent bond using bond formation in CH3Cl. So this is C, we have H, H, H and Cl. So C has 4 outside, means it wants to combine all these 4. Hydrogen will combine with 3 and chlorine will combine with one of these. So carbon can neither lose 4 of its electrons nor gain 4 of its electrons, as both the process require extra energy, and that is going to make this system unstable for carbon. In order to complete the octet, it completes by sharing 4 electrons with other carbon atom, or it may be atoms from other element, as we see here. It can combine with carbon, it can combine with any other element, like here we have hydrogen and chlorine in this case. So the bonds that are formed by sharing electrons, these are known as covalent bonds. These are covalent bonds. Co means they are cooperating, and they are cooperating with their valence or valent electron. So in covalent bonding, both the atoms share the valence electrons. So say this is A, B, A has this, B has this, so they share these. The shared electrons being the valence shell of both the atom. This is A's, this is B's. So carbon requires 4 electrons to complete its the octet. What about hydrogen? Hydrogen atom requires 1 electron to complete its duplet. So hydrogen is completing its duplet here. And what about chlorine? Chlorine requires electron to complete the octet. So it already has 6 or 7, and this 7th one will combine with this one, so it will make its own octet 8. So all these cases share the electron as a result. Carbon forms 3 bonds with hydrogen, 1 this one, 2 and 3, and then 1 with the chlorine, which you see here. Draw the electron dot structures for ethanoic acid, H2H, propanone and F2. So this ethanoic acid is C2H3H4 NO2, right? So there are 2C, 2O and 3H. So first we'll take this first carbon combined with 3 hydrogen, means making covalency or covalent bond with them. Then this carbon making with one with carbon, other with oxygen, other with another oxygen, and 1 oxygen combining with hydrogen. Hydrogen sulfide, because sulfur 1, 2, 3, 4, 5, 6 it needs 2 more, so it will take 1 from hydrogen, 1 from hydrogen, another hydrogen, and hydrogen will take 1 from this one, 1 from this one. So it is making its duplet. Sulfur is making its octet. Propanone. Propanone is C3H6O. So C, these 3 C combine. Now these 3 will a carbon, because 1 has been combined. So 2 carbons will covalency or make covalent bond with 3 hydrogen. Here also 3 hydrogen, and then this carbon will combine or make a covalent bond with oxygen, all making their octet and duplet. F2 fluorine. Fluorine has 7, it wants 1 more. This fluorine has 1, it wants 1 more. So this is how F2 is formed. What is homologous series? Explain with an example. A homologous series is a series of carbon compounds that have different number of carbon atoms, but they fall in the same functional group. For example, methane, ethane, propane, butane. They all are part of alkane homologous series. The general formula is CnH2n plus 1. Just place 1 here. This will be C1. H 2 into 1 is 2. 2 plus 1 is this 2n plus 2. So 2 into 1 plus 2, that is 4. So CH4. Methane. Now you put 2, you put 3, you put 4. You'll get ethane, propane, butane. And you must notice here the difference of each of them is CH2 unit, successive compounds. How can ethanol and ethanoic acid be differentiated on the basis of their physical and chemical properties? First is ethanol is liquid at room temperature. It has a very pleasant odor. When we talk about ethanoic acid, it has a vinegar-like smell. The melting point of this ethanoic acid is 17 degrees centigrade. That means it's below temperature, room temperature. So in winters, it is going to freeze. Ethanoic acid react with metal carbonates and metal hydrogen carbonates to form salt, water and carbon dioxide. As you see here, it combines with metal carbonates and metal hydrocarbonates. This carboxylic acid, this is exactly this one. So carboxylic acid is combining with either of these, and it will form salt, water and carbon dioxide. While ethanol, if we take the result of ethanol, it does not react with them. It doesn't react, no reaction, right? In the electrolytic refining of a metal M, what would you take as anode, a cathode and electrolyte? So the question is, this is anode, this is cathode, here is electrolyte, anode, cathode, right? So first is anode, it has to be impure metal M, cathode has to be pure metal M, and this solution, electrolyte solution, should be the salt of metal M. Why are carbons and its compound used as fuels for most application? See, there are various property of this carbon and its compound that makes it ideal for application or employed as a fuel to produce energy. First is they give a lot of heat and light when they are burned in air, and when they are burned in air, these saturated hydrocarbons, they burn with clean flame, no smoke or least smoke is produced, and they also provide high energy, high calorific value. That is why they are used as fuels for most applications. Explain the formation of scum when hard water is treated with soap. Now when soap combined with hard water, it doesn't gel that much, right? It's very difficult. So there is a scum or a precipitate being formed. So soap does not work properly when the water is hard, because soap is what? Soap is a sodium or potassium salt of long chain fatty acids. So this hard water contains salts of calcium and magnesium. If the water is hard, it contains salts of calcium and magnesium. So when soap is added to hard water, calcium and magnesium ions present in water, they actually displace this K and Na, sodium and potassium ion, from the soap molecules, and they form a precipitate, which is an insoluble substance called as scum, and a lot of soap is wasted in this process. What change will you observe if you are going to test this soap with litmus paper? See, this soap is basic in nature, so it is going to convert the red litmus to blue. But one thing you need to consider is the color of blue litmus will remain blue. What is hydrogenation and why is it important in industrial application? Hydrogenation, as the name suggests, application or addition of hydrogen. Now hydrogenation is the process of addition of hydrogen, as we suggested. What happens here is the unsaturated hydrocarbons, as you see here, are added with hydrogen in the presence of nickel catalyst, or it can be palladium, and it gives rise to saturated hydrocarbons. So that this reaction is applied to hydrogenation of vegetable oils, and that contains long chain of unsaturated carbons. Which of the following hydrocarbons undergo addition reactions? See, the unsaturated hydrocarbons, they will undergo addition reaction, and which of these, or the unsaturated carbon category, which of these fall? C3 H6 and C2H2, these two, 1 and 2, they undergo the addition reaction. Give a test that can be used to differentiate chemically between butter and cooking oil. See, butter contains saturated fats, so it cannot be hydrogenated. On the other hand, if you talk about oil, they have saturated fats. That is why it can be hydrogenated to saturated fats, solids. Explain the mechanism of cleaning action of soaps. So the dirt, see, this is a dirty cloth, this is the dirt, and this is a soap solution, right? And this is soap solution, all this dark blue, and these are soap molecules. So the dirt which are present in cloth, they are organic in nature, and if they are insoluble in water, just water is not going to take them out. So it cannot be removed by washing only with water. But when we dissolve soap in water, these hydrophobic ends, they attach themselves to this dirt and remove it from the cloth. See, they are attaching and they are removing it from the cloth. Then these molecules of soap arrange themselves in a mishal form like this. This is a mishal form, and trap this dirt at the center of the cluster. This mishal remain suspended in the water, and then you can just throw that water, so the dust particles are easily rinsed away by the water. So these were questions and answer on carbon and its compound. Thank you so much and take care of yourself.